Here is the second problem from this chapter 10 classwork. We hopefully just finished watching the video going over the world population problem. Now we're going to do something about the year, explaining the number of mortgages in millions of dollars. It doesn't tell me where. National banks, I'll just say the United States. Okay. So again, it asks me to scale. So I went ahead and scaled the years from 1970, and it said to use 1970 to 1988. So I'm going to go ahead and delete out my 1990, my last three here. So just because it only said to use until 1988. So give me a moment here and clear that out. Let me delete those. So delete, and then the last three over here also delete. Okay, so let's see what happens when I graph the scatter plot for year explaining the number of mortgages. All right, so we have graph, zoom 9. Okay, and that looks like a pretty distinct curve or bend in that pattern, so it's not okay to use a linear regression model at this moment. So as I mentioned in the last example, I'm going to be referring to this ladder of powers on your notes. So right now the raw data didn't work because the form was not linear. So let's square all the y values. I'll go up to the next one, which is to square the y values. So remember to go up to L3, hit second L2, and we want to square all of them. Okay. So now I'm going to do my scatter plot, but this time it's list 1 as my X and list 3 as my Y. All right, so hit graph, zoom 9. And that made it actually worse, right? It made that curve even more pronounced. So that didn't work. So the next is I tried squaring the Y values. The raw data, as we mentioned, didn't work. So let's take the square root of those Y values. So go to stat. And we're going to go over to list 4, like we ended up doing in the previous example. So do second square root of list 2. All right, and so now I'm hoping that this scatter plot will look more linear. So go down to your Y values and do list 4. So second, number 4. All right, graph it, then zoom 9. Okay, it's looking a little bit better, but I still kind of feel like there's a little bit of a bend there, especially kind of in the first few, or a little bit of curve. So let's see what happens the next one. And you're going to see, guys, when we do the chapter 10 quiz, not for a grade, but in class, we're going to do it together. You're going to see that this essentially, whenever re-expression comes up on the AP test, like 9 times out of 10, it's just going to be the re-expression using logarithms. So really, the slide that you end up kind of using more is this one here, where I'm going to first try taking the log of my Y values to see if that works, then trying to take the log of my X values, graphing it to my original Y values. And then that doesn't work, take the log of both of them, right? So they call it, as a joke, the Goldilocks model. Kind of funny. But anyway, so let's go to stat. We're going to end up going to list 5. And I want to do the logarithm of list 2. So log is this button here. All right, so the log of list 2 Y values, right? Those are my original Ys. And let's see what happens when I graph those compared to my original X. So keep the list. You notice that at this point, I haven't changed list 1 out of X. Just been changing the Ys. So let's do list 5. And we're going to do zoom 9. And sure enough, that looks more linear. Yes, it still has a little bit of dip on that 4th square, but it looks overall more linear than that square root one. So I'm going to stop here. I'm going to run the regression model. All right. And I'm going to put it into, so number 8, I'm going to put it into, make sure you do, this is list 5. All right. Make sure you put it, or at least you don't have to, but I'm going to put it into my regression equation because it's asked me to do some predicting. So hit vars, y vars, function, y1. And then I want to calculate, right? Remember, before I write this down, I'm going to make sure to go to my residuals plot to see if I see a cloud. So hit second, stat plot. But if you don't run that linear regression first, you won't actually have any residuals to plot. So now hit second, list, number 7. Graph, zoom 9. Oh, I should have taken, hold on one second. Let me take out that equation so it's not getting in the way. So just kind of take a moment, put it away. All right, so graph, zoom 9. And that looks like, I mean, maybe you could convince me there's some fanning going on, but kind of no pattern, maybe a little bit. But I'm going to stop here because, again, you've done 4 different ones, really. So I'm going to go ahead and stop here, use this model with the logarithm of my y value. All right, so hit calculate just to get those numbers again. All right, now as I mentioned in the first example, right, we ended up deciding on a re-expression. So when I write down my model, I'm not going to be writing down like mortgages, right? Or sorry, just mortgages hat. It's the log of mortgages hat because we decided on taking the log. All right, and then my y-intercept is 0.146 plus slope of 0.074 times, and this is years since 1970. Okay, so it wants us to look at, I'm just going to pick one of them past the 1988. So let's just pick the 1990 because we actually have, I guess we could go ahead and do all 3, but I'm going to show you the work for 1990 and then I'll just do my own work to find 95 and 2000. So I'm going to find the log of mortgages hat equals 0.146 plus 0.074 times, and 1990 is 20 years since 1970. So I'm going to hit vars, yvars, function, y1, and I'm going to plug in, evaluate this at 20. All right, so I get 1.627. All right, but remember, that is the log of mortgages from 1990 is 1.627. But again, I won't be rounding when I use my calculator. So if you remember how to get just mortgages hat by itself, right, essentially to get rid of the log, we have to, which I'd love to say is we have to swoop. So if this is log base 10 of mortgages equals 1.627, I am going to do 10 to that power is equal to the number of mortgages. So 10 to the 1.627 power equals mortgages hat. All right, so in my calculator, I'm going to do second 10 to the power of x, and this is where I'm going to type in that number to give me my number of mortgages, which is in millions, 42 looks like they rounded, so I'll do $42.4 million. So $42.4 million. Okay, so writing this to the side, right, because these are the predictions. So that's 42.4. Let's do the same thing for 25 years. So do vars, yvars, function, evaluate this at 1995, which is 25 years since 1970. And do the same thing, 10 to that power, right? Because I want to get rid of the log. So that gives me 99.34. And then finally, 30 years. So I'm going to have vars, yvars, function, y sub 1 evaluated at 30. And then do 10 to that power, which gives me, 232.9 or 233.0. Okay, so really when you look at this, right, if this didn't make it clear from the last example, that extrapolation is something that you should very, very much avoid. This made it very clear that we should not extrapolate. Remember, our model that we made, right, the model that we made was from 1970 to 1988, or I should say the model we made is based on 1970 to 1988. So when we plugged in and extrapolated past that, 1990 was
42 is just 10 million higher. I know it sounds silly to say just 10 million higher. So it was kind of close, but then 1995 was 60 million higher. And now we're talking about approaching 200 million higher in 2000. So very much don't want to use this model. So clearly I would need to start a new model and maybe look at separating out 1990 to more current to see if that makes more sense in terms of models. All right, so that's number 2, where you got a chance to re-express using the logarithm. Tune in here in a moment for the third one.